Hello everyone, I am Siven Verma from Polyvariate Frameworks development team. With me I have my team member Rahul Yadav. Now we are going to discuss control validation pipeline of Polyvariate framework. So this slide have high level architecture of control validation pipeline. Like other pipeline, here we can also write scenarios using Scenic, and we are running all our scenarios in LG Simulator. We already have written plugins to capture relevant information, objects information, control information into the logs from LG Simulator. From Autoware Auto, we are running all relevant required nodes, for example, object detection node, control initiation node, and we are logging objects and control information. Inside Polyverif, already we have implemented algorithms to capture parameters. Few parameters are like time to collision parameter, which we are calculating per frame basis. We are calculating response time for LG Simulator and for Autoware. We are also monitoring controls responses. For example, brake applied or not applied. Let's discuss in detail about control validation parameters. So here we have written formula which we have currently implemented for time to collision calculations. Here we are considering ego vehicle's speed and length. So we are also calculating response time. So this response time is the time of ego vehicle to apply brake, which can avoid any collision. We are also calculating delay in response due to perception. So there is possibility due to the perception we can detect objects with some delay. So that delay we are also capturing. Let's talk about some scope. So currently we have written scenarios for highways considering front and rear collisions. In future we are considering collisions from all the directions with static objects, with dynamic all type of dynamic object. We are also planning to consider human motion for future races. Now let's run one video and run one scenario. So hi Rahul, can you explain how Polyvariate framework is running scenario inside Polyvariate framework?
Yes, Shivendra. So we are running our simulation script using the autonomous valet parking demo of Autoware Auto. In AVP demo, it start all the supporting and relative nodes that provide feedback of control to the LG simulator. Once the node are start and up, we can start capturing all the relative data of ego vehicle in the log file. For that, we need to start the AVP demo and set the initial position and goal position that are published on ROS2 bridge by clicking on these two buttons, which is initial position and goal position. That sets initial and goal position used by the Autoware Auto. Hope it is clear to you.
Okay, Rahul. So here we can see in video currently we have selected scene, then we have selected that scenario, then we are running AVP demo. When we start AVP demo, it opens RViz window, which is Autoware's visualization window. So we are, after starting the scenario, we are setting initial position and goal position. So here in LG Simulator, we can see already vehicles are there, and ego vehicle can see those vehicles. Similarly, in Autoware Auto have started their nodes, and object detection node is detecting those objects. So those are shown here as a yellow boxes. Also, this auto is running path planner node, so the plan path is shown here in green line. So now we can see this ego vehicle is traveling decided path. Here we can see that vehicle is clearly visible, but in AutoWare is not able to detect that vehicle. We can see clearly, still that is not visible. Yeah, now we can see this vehicle, this ego vehicle is able to detect this object, but there is possibility that this time is very less, so there is no possibility of avoidance, collision avoidance. So yeah, collision happened. So let's now check the parameters, how parameters are explaining this collision thing. So now we are stopping the scenario and then we are running our algorithms. Yeah, so once algorithm is run, we are showing this parameters. So here we can see response time of ego in LG simulator, because in LG simulator from start obstacles or vehicles was visible, so there was time to apply controls, so their time was 2.33 seconds. But in AutoWare, perception was not working properly, and because of that ego vehicle was able to detect object with only nearby that vehicle. So here we can see response time of only 0.96 second. So there is delay of 1.38 second. So here this parameter is saying that brake was applied. So ego vehicle applied the brake, but there is possibility that time was less or brake applying force was less. So this collision happened. So this is the conclusion from parameter. Now see the summary window. So as collision happened, so we have declared this scenario as a failed scenario. So this was Polyverif's control validation pipeline. Thanks for your time.